In this video, we're going to look at Chapter 8, Section D on continuous data. Remember that continuous data is another form of numerical variable, and that the values for these variables can take on any value along the number line. And we often find these values through measurement. Instead of counting like we do for discrete data. To give you a visual, if I have a number line, continuous data can be found anywhere along this number line, including between the whole numbers or the integers, so decimals are okay. An example of a numerical variable data is if I was to measure the height of all the members of the basketball team. And I can get any range of heights, including decimals and fractions. For example, I could get 6 feet, 7.5 inches, which is not possible with discrete data. Just like with discrete data, we have ways to organize and visualize continuous numerical variables. One such method is the frequency histogram, which looks a lot like a column graph for discrete data. Also, when we measure continuous data, we're likely to get many different values, so the data is often grouped into class intervals. And we saw class intervals in the last video on section C. So here's an example of a frequency histogram for continuous data. There are a lot of similarities here to the column graph, as I've said. We put our variable on the x-axis, or the horizontal axis, or the values of our variables, and we put the frequency on the vertical axis, or how many times a data value falls within a specific class interval. And we use columns to represent the frequency. So the height of the column represents the frequency of the data value. The major difference between a frequency histogram and a column graph is that there are no gaps between the columns. And this is because the data is continuous. So we represent the continuous nature of the data by excluding the gaps between the data. Because really, I could be flowing very easily from one class interval into the next. Again, just like in the last video, the class that has the highest number of occurrences is the modal class. And to just emphasize the point or the differences between frequency histograms and column graphs, here's a quick visual. Again, notice the similarities. We have our data on the x-axis, we have our frequency on the vertical axis, and we use columns to represent those frequencies. However, in a column graph we have no gaps, we have gaps, and in a frequency histogram we have no gaps. To be clear, we use column graphs for discrete data, which are usually found by counting, and for a frequency histogram we use continuous data, which is usually found by measurement. Let's take a look at an example problem. This example problem can be found on page 182 of your textbook, and in this problem we're given the weights of parcels sent out on a given day from a post office, and the weights are in kilograms. And we're asked to organize the data using a frequency table and then to graph the data. So before we graph the data, we want to organize it using a frequency table. And in our first column we'll have the variable, which is weight, and it's measured in kilograms. And in the second column we'll have the frequency. Now again, we want to use class intervals here. So we want to look at the data and figure out that most of our weights, or all of our weights, are above 1 kilogram, and they're also all less than 6 kilograms. So I can break up my data into class intervals as follows. Now notice the symbols I'm using here. I have 1 to less than 2. This means that 2 is not included in the first class interval. So if I had the value 2.0, it would actually go in the second class interval, which is 2 to less than 3. And again, if I had the value 3.0, that would be in the third class interval. So this is very important notation here, and which you should remember when you're writing a frequency table for continuous data. Now let's circle all of the data points that fall within the first range. And you can see that I only have 2. I could do the same thing for all the other class intervals, and I find that I have these frequencies. So this is the first part of the problem. I've organized the data using a frequency table. And now I want to graph the data. And I'm not going to draw this, but I'm going to show you what the graph would look like. So notice on the x-axis, or the horizontal axis, I have my ranges. And notice on the numbers are placed between the columns and at the ends of the columns, whereas in a column graph, the numbers are placed at the center of the column. That's because we're using continuous data here. So the data values in this column could fall anywhere from 1 to just less than 2. And likewise, the data in this column could fall anywhere from 2 to just less than 3. I also have my frequencies for these columns. So for the first class interval, I have a frequency of 2, so the column is raised to a height of 2. And we do the same thing for the other columns. And this is our frequency histogram. We see that the modal class is the class, or the data values, from 3 to just less than 4. Now I could also organize this data using a stem and leaf plot, which we learned about in the last video, and I'm going to quickly just show you what that would look like. So from this stem and leaf plot, again we see all of the data values, which is the advantage. It's not a graph, but we can easily pick out the modal class, the minimum data point, and the maximum data point. And it's important to note that in this case, the line between the stem and the leaf represents a decimal point, so that these values are 1.3 and 1.6 and 3.1 and 5.2. I can also perform very similar data analyses as I did in the last video. So if I wanted to find the percentage of data points that were greater than 4.6, I could do that as well.